Oh, hi there! I didn't see you. It's a lovely day here at Worcester Polytechnic Institute. A great day to learn about an incredible and strange type of material that you can make in your own home. So to start off our talk today, I want to ask you a question. What are the three phases of matter?
Which of these are phases of matter? Gas, cauliflower, energy, liquid, solid, or uranium?
That's right! The three phases of matter are gases, liquids, and solids. What do these phases actually mean? Gases are the most variable phase of matter. A gas can change in both its shape and its volume depending on the container that you put it in. Solids, meanwhile, are the most structured phase of matter. A solid will keep its shape and volume regardless of the container in which it is placed. Liquids are somewhat of an intermediate. A liquid will maintain the same volume regardless of its container, but its shape will change. Now, these three phases of matter cover most of the materials we see in our everyday life. The air we breathe is a gas, the water we drink is a liquid, and the ground we walk on is a solid. But what if I told you that some materials don't really fit into the definition of those three phases? We're going to be talking about some of those materials today. Hi again. Yeah, so that special type of material that I was talking about is called a non-Newtonian fluid. A non-Newtonian fluid is a material that acts like a liquid under most conditions. However, when you apply a force to it, it begins to act like a solid. One example of a non-Newtonian fluid that you may have heard of and that we're going to be talking about today is Oobleck, which is just a mixture of cornstarch and water. So why does Oobleck behave the way that it does? Oobleck, when placed alone in the bowl and with no force applied to it, flows just like a liquid. But if you squeeze it, or step on it, or apply a pressure to it in any way, it behaves like a solid. There are many non-Newtonian fluids that you might be familiar with in your life. In addition to Oobleck, slime and silly putty are examples of non-Newtonian fluids. Right. So now I'm going to walk you through how to make Oobleck on your own. So the recipe for Oobleck is pretty simple. For materials, you're going to want to have a bowl to put your Oobleck in, kind of like this, a spoon to mix it up, and somewhere where it's okay for things to get a little messy. So we're working outside to make our Oobleck, but especially if you're working inside, you're going to want to have some napkins and towels on hand, because while Oobleck is a solid when you hold it, it turns back into a liquid very quickly and tends to spill everywhere when it does so. So now for the actual materials you need to make the Oobleck, you're going to want some cornstarch, some water, which is in this Tide Pods container, and some food coloring. You can pick any color, but I'm using blue. First off, you want to get 1 cup of cornstarch. 1 heaping cup of cornstarch into your bowl. That's about 1 cup right there. You might need to add more cornstarch depending on your Oobleck, because sometimes the starch can have different amounts of water to start off with, so it can have different properties. Once you have your 1 cup of cornstarch, you want to measure out 3/4 of a cup of water. So here's 1/2 cup of water, and here's 1/4 cup of water. So yeah, now all you need to do is just mix the starch and water together. Just like I'm doing here. You want to make sure to get it really uniform, which might take some time as the starch gets pretty thick already. So as you can see right now, after some mixing, which might take a couple minutes, my Oobleck is looking pretty consistent. So and you can see that when I touch the Oobleck and apply pressure to it, it acts like a solid, like it's supposed to. So now that that's all set, we can add in some colors just to make our Oobleck look cooler. So we're going to add blue. Once you have your food coloring in, you just want to give it some more mixing just to help get this color all throughout the Oobleck. There we go. Look at that. So now that our Oobleck is all mixed up, it's nice and blue, I'll just show you some of the properties that it has. So as you can see, I can scoop up some of it in my hands here. If I just let it rest, it acts like a liquid flowing out of my hands. If I press on it hard in my hands like this, see it stays like water. It's a little tough to view, but if I press on it, it forms a little solid block that then goes back to being a liquid once I let it go. So why are we talking about Oobleck here today? Oobleck is not just a cool demonstration of the unique properties that materials can have, but it also has relevance to science and engineering work that can save lives. You see, many scientists and engineers, especially those within the fields of biology and biomedical engineering, design devices that must be implanted into people's bodies to help them live. These devices must interact with bodily fluids, such as blood. These bodily fluids actually are non-Newtonian fluids. So on a smaller scale, they behave in a similar way to Oobleck. So by making this Oobleck and playing with it and seeing its unique materials properties, you're kind of seeing the kind of work that scientists and engineers must undergo to understand how these bodily fluids work, so they can design the devices that keep people alive. We hope that this video was useful to you in your Girl Scout career and interesting as you complete your badges. And we thank you so much for your time here today.